Okay. Did the little thing come up saying it's being recorded? There we go. Cool. Okay, so it's being recorded. Okay, so tonight's topic is getting started with Azure Kubernetes Service. I've posted a question in the chat. If anyone actually has questions they're looking to get answers to tonight, go ahead and post them, and then we can make sure that we get them covered, or at least address them. I've given this talk a few different times, and I've seen several different getting started about Kubernetes or getting started with Azure Kubernetes. So I've tried to structure mine a little bit different. I won't actually be going to the command line very much, but I should still be able to show you with most of the tools that I use on a day-to-day basis what I need to do, or what you need to do in order to get started with Kubernetes Service. There's a bunch of other videos and tutorials. Oops, I was going to switch screens, but I guess not. Let me switch my camera around here. So let's get started. So the agenda's been moved around a little bit. I've given this talk, I don't know, 3-4 times, maybe half a dozen at this point. So it's always different. I've changed it a little bit this last rendition for the code camp up in New Hampshire because I needed to fit it into an hour. Tonight we don't have that time box of an hour, so I can actually spend a lot more time in the demos, which will hopefully you'll get more out of it for spending time in the demos. So I've structured it so that all of my demos kind of piggyback off of each other, which helps with the time. I'll start out with some theory and basics with the containers in Docker. Then I'll show you some Visual Studio tooling, because I use a Visual Studio. Visual Studio Code also has quite a bit of tooling around Docker and Kubernetes, but I'm not going to get into that tonight. It pretty much compares. It's looks a little bit different, and you access it differently, but it compares feature-wise. But I won't be showing that. Then we'll talk about some of the high-level Kubernetes stuff, because Kubernetes is so deep. There's really little you can do in a part of a 2-hour conversation, let alone anything shorter. Then I'll talk about Helm and how it can be used. Azure DevOps, which is that's the CI/CD pipeline that I'm most familiar with, getting projects deployed into Kubernetes. And then finally, we'll land on the Azure Kubernetes Service. So all of these other things are pieces and parts of what you're going to need to know to get Kubernetes into production in the real world. So that's kind of what I've structured this talk for. Things that I have learned along the way, and things that I've found useful. And there's a lot of resources at the bottom of this PowerPoint deck. So I'll post this online. I'll put a link to it in the meetup so that you can download it afterwards to get all the resources. But each of the sections, I've got a resource list that goes along with each section. So several good books and videos and things that I found useful in learning these topics myself. So I'll go ahead and get started. So container and Dockers. Oh, and I'm going to stay out of the presentation mode because I really do plan on spending more time on the demos than the presentation mode. And I just get confused with the presentation mode quite often with the sharing. Sometimes it just doesn't do too well. So you get to look at my deck. And you'll see that whenever you do, so I'll link the deck, and whenever you download it, you'll see that several of them have quite a few notes at the bottom with additional resource links and just notes that I've taken given this presentation. So containers and Docker, chances are pretty good. Let's see how many people we have on. We have 20 people on. So the chances are pretty good that you all have heard a bit about containers, what they're for, what they are, and you've most likely heard them compared to virtual machines. So I'm not going to spend a ton of time on this, but this is how most people explain what containers are. They say, oh, well, a virtual machine virtualizes the hardware, where the containers virtualize the OS. And what that really means is when your application, so let's take, for example, a web application that has some services behind it. So you've got, say, 2 things running, and in the VM world, you would have the web application on one VM, and then if it was a web API, possibly on the same VM or possibly on the other VM. If as soon as you try to put multiple sites on one VM, sooner or later you're going to run into that problem where they share a dependency, but one of them has got a new version and the other one's got the old version. And when you start doing cross-dependency issues and sharing of dependencies, you get surprised when the latest fix that you put out actually broke something else. You know, it's like putting your finger in something. Sorry, my alarm's going off here to remind me to start the recording. You put your finger in one place and water starts coming out somewhere else. So with VMs, you kind of ended up moving to having one VM per application, which is kind of expensive. And that's what's showing in this diagram is you've got this extra layer that's called a guest OS. So the hypervisor was on the hardware, so that allowed you to run multiple VMs on that same hardware. It was great. It allowed you to utilize the hardware more, but it's all the resources that OS is taking when you start stacking only one app in a VM starts to add up, especially if you want to get the most out of your hardware. So the cool thing about containers are they don't have that extra layer of the OS. So all those CPU cycles and memory that OS is taking up, and not to mention the disk space, isn't necessary to duplicate across whatever's running your container. The container itself is really, it's like a zip file system of what is needed to run your application. So you can have multiple containers running on the same OS, and all of their dependencies are going to be contained within them in themselves. So they're not going to step on the other application that's running on the same machine. So that, at a kind of high level, is what containers are. It's this phrase up here is kind of how I've come to think about it. You know, they're just isolated processes running that zipped file system of your application running on a host machine, as opposed to a VM being a whole virtualized machine with all your files spread out across the file system on that machine. So kind of a long way of saying what containers are, but the chances are if you're doing anything with containers, you are doing it with Docker. It's not the same across the board. There are multiple Docker competitors. There's more now than there used to be, but the playing field that we're looking at now, Docker is really the one that revolutionized the ability to create containers, and not because containers were available for Linux long before Docker, or the equivalent functionality that containers utilize was available in Linux long before Docker came along. But what Docker did is they not only made them easy for just everyday people to run images and have all that isolation to be able to pack more stuff on each individual machine, they made it cross-platform. So not only could you do it on Linux, you can now do it on Windows and Mac. And that's where I believe the growth really took off, because then it wasn't just people running on Linux machines. It's now people running on Windows machines, because you could run a Linux VM on a Windows machine, but you can now develop something on a Windows machine that's going to run on a Linux machine. And Mac, same thing. So Docker really brought this to the mainstream, and that ecosystem is constantly evolving. And there, of course, these days, with anything that really gets popular, you're going to get competitors in the environment. So what happens when competitors start showing up with competing container runtimes and container images? Because you've got two parts to the container aspects. You've got the actual image that has your application, but then you have that runner that knows how, that runtime that knows how to utilize that and run it as an application. So Docker spearheaded the initiative to create this open container initiative, which kind of wanted to standardize a container runtime and image, so that when other competitors came into the point, they kind of had to follow the lead that they had started. That's kind of the viewpoint that I see on it. But now it's made it so that it's standard, and that one image that you create on one runtime or one tool set to create the image can most likely run on another image as long as they meet the Open Container Initiative. So they standardized it as well as really brought it to the mainstream. And if you're doing container development on Windows, you're most likely doing it with Docker Desktop. Once you install it, it's going to show up as an icon down in your tray. I'm not sure if the shares my tray, but whenever you open it, you'll get this little application showing up, and some settings, and then we'll see this a little bit later in the talk here. But Docker is the one that really made the containers mainstream. Now, the thing that I kind of brushed over with containers is you get this image, and it's sizable, but it's stored in layers so that you get a pretty efficient caching on the layers. So the idea is you're building this layer that starts out with the OS that you want to virtualize, more or less, and then all of the things that you get installed on top of that. So the idea is that that base layer that you started off with doesn't change very often, but your application that you layer on last will change every now and then. So it'll be that last layer that needs the latest download when you put a new copy of your image up there. So the caching is really efficient. So you don't see that 250 megabyte image has to be pulled every time. So if you're pulling the image multiple times on the same machine, it'll just utilize the cache. And that comes along with, okay, so you're pulling these images or this tarball or zip file of your dependencies in your application. It's rather sizable. Where do you store that? You need to store it somewhere else so that you can pull it into your application where you're going to run it. That's what they call a container registry. And there are multiple flavors. You can have a public or private registry. The most popular one, of course, is Docker Hub. And then their Azure Container Registry is a private hub so that you can put your own assemblies in there. And you're going to want you're going to want to use a container registry that's close to where your production environment is, so that, because they're not small, and like I said, once you pull them across the wire once, the caching is going to kick in, so you're not going to be pulling them across every time you spin something up. But if you bring up a new node or you bring up a new environment, you don't want to be bringing them all the way around the globe to land in your production. So you'll want a container registry in the same data center that your production is. And with Azure Container Registry, the higher level, I think it's the premium level, you can replicate. So if you have multiple data centers, you can have your containers hosted in multiple data centers around the world, as opposed to having to have a single one and then copy things over yourself. So that's container registry. That's kind of the high level Docker container basics that I wanted to highlight. Now let's look at what you can do in Visual Studio 2019 in an example. You can do quite a bit with Visual Studio 2019 and not have to fall out to the command line. And especially if you utilize the Docker Hub app on your machine, there's very little you actually have to do on command line. So let me show you an example of that. So let's go to the demo slide here. So let me open up a new Visual Studio. So do we have any questions before getting into the demo? No, I don't see any. All right, cool. So let me just do a new project. I'll do a simple ASP.NET application just to show you the example here. I'll also point out, so you could enable Docker support as you're creating your application here. I'm not going to, because I'm going to show you how to do it with an existing application. So I'm just going to create this. But once you enable it, you're going to need to then choose, do you want a Linux container or a Windows container? Because they're not compatible. You do have to make that decision. Do you want to use a Linux-based OS or a Windows-based OS? And the biggest difference is going to be the size of the image. The Windows images are so much bigger than the Linux images. So this is your typical ASP.NET core application out of the box. Let me show you it running here. There's no Docker goodness in it yet. We're just going to see an application come up. This is the command line, so we'll see what comes out to the command line. Should see some trace statements and then a web application pop up. Typical stuff for an ASP.NET application. So now let's Dockerize this thing. Visual Studio makes the starting point really easy, and getting into the more advanced is going to kind of be up to you to learn. What you'll find to be pretty much fooling around with the Docker file and learning how to do more advanced stuff whenever you need to. So it's asking me which OS do I want it to use for the containers. And that's it. It added a Docker file. So if I open the Docker file, and the Docker file is pretty much a manifest that Docker's build tools will utilize to create a container image. And it's, again, this is the stuff that's not going to change very often. You put things that are pretty solid at the top. This is the base image that we want to use. It's a Buster Slim image, which I believe is Ubuntu or Debian Linux. So this is the base image that we're going to use, and you can see base is used again at the bottom here. So this not going to change very often. This will change because this is taking our project, restoring it, so it gets all the dependencies, and then it builds the project, and then it does a publish so that we can narrow down just the output that we want running in this image. And then it copies the stuff from publish here that was the output of our build onto the image here. So that's the final. This is I believe they call this a multi-stage Docker file. There used to be this, so the Docker file syntax changed over the years, but this is the most common now, because the idea is you want this container, the final container, to be as small as possible, because the bigger it is, the more seconds it's going to take to spin up, no matter where you run it. So you want it to be small and compact as possible, and it takes less memory, takes less resources in general. So I'm not going to get into this, but this is where you're going to spend most of your advanced research, if you will, is going to be whenever you need to like add addition. Say you've got a PDF generator and you're doing invoices. You're going to need to install fonts on the Linux file system. So you're going to need to learn how to do that, and then Google for that. Do a bunch of digging. It's always case by case scenarios, but that's when you'll find that you do the most with this Docker file. So this is what will actually end up build the image. Some things that Visual Studio gives us, because I right-clicked and said Dockerize it, is it gave us the Docker file. If you look in the project file, you'll see that it actually set a Docker file context, and it sets the OS in the project file too. Now the Docker file context is going to be important to you if you've got a file structure a few levels deep. So say this is a big solution and I've got a couple layers deep, but I have dependencies that need to be copied in to do the build. This is where you would want to play with that Docker file context. And as you start to learn to build Docker files and all that stuff, you'll learn more about the context for the Docker file context. But this is important. I often have to change this because dependencies that we typically use are a couple layers deep. So I'll have to change this to like ... whack ... or something like that. But I don't need to do it for the simple one. But that's nice that they put that in there. They didn't used to put it in the project file. You had to know to add it. So that's those two things that they add for you. They add this ability to debug the Docker container using Visual Studio, and that surfaces itself in the properties here. So properties, launch settings. It added some stuff to the launch settings here. So this got added. That's what allows this button to show. If I run it and you want to really understand what it's doing for, because it's just using the Docker command line under the covers, all of this stuff, if you look in the output, let me pull this up here. If you look in the output window, I'm too slow. In the output window, and choose the build. Which one was it? Build package managers. One of these guys, container tools. Okay, so it's container tools. It will show you as if you were building this on the command line. Here's the Docker file. So here's Docker build. So this is the command that it's sending off to the Docker image. So this, you could copy this and do it on the command line, and it would give you exactly what the Visual Studio is doing. But you'll see they send it quite a bit of stuff, and this is the magic that allows you to actually run it in Docker. So we've got the web app up running. You can see it's using a different port than it was coming up earlier. I believe it was 5001 earlier. By default, when I was just running as a .NET Core exe on the system, it's running as a container now, and this container is mapped. It has a volume mapped, which a volume is really more or less shared storage that's connected to the container. And that shared storage is the file system that I have for my web application. And I can prove that here in a second. So, but if I go to, let's go to pages. Oh boy, I'm not super up to date on this stuff. So let's go to the index. This is Razor file, and I'm used to the old MVC stuff. So if I go back to here and I hit refresh, it hits a breakpoint. Even though the logic is actually executing in the container, I can step through this in Visual Studio. And that's useful. It does come with some caveats, which I'll get to. But oh wait, let me show you the files. Prove to you that the file system is actually on my. So let me open this up in my Explorer here. So file system is here. All right. So this is the file system. I'm just going to add a text file at the root level. But first of all, let me show you the containers window, because this is really the killer app for Visual Studio's container tools, is this window right here. And you'll find whenever you're fooling around with Docker files, if you have to do anything outside of this simple template that they give you, when you're beginning, you know, because you can see we're doing some copies, we're doing some building, and then, you know, what files get created, are there any extra files there? You know, you might be wondering what's actually in the container, and then you do this copy over to the final, and you may wonder, well, did the file that I thought was going to be in a certain location, did it get copied? That's what that's where these tools really come useful. This little tab right here says files. It shows you the file system of the container. So you can see right here it says app. This is my app. This is the directory mapped to this. You can see it actually has a CS project file, a solution file. Those wouldn't be published in this release publish here. So let me prove that. So if I go and I say, let's do a new text file. We'll just do a blank text file. And okay, so that is there. So now let me refresh the file system in here. So what's in this container? And I open app. Now that new text file is there. So this is not the files that are zipped up into a typical container. This is a shared volume using Docker volumes and the ability to access that stuff so that they can allow you to do debugging in Visual Studio. So this is the actual file system on my machine, but it's running inside of a container. A little complicated, but it's very useful. If you find a file in here, actually, since this is my file system, it's not going to do me much good, but if you're really debugging an image, which I can show you, you can download these files, or you can open these files. And what it's going to do is it's going to copy the file out of the container and then open it up in Visual Studio if it can. Because with the Docker command line, you may not know this, but you can copy files out of a container or into a container with command line, and that's all it's using under the covers. There's also a source directory down here. It's mapped pretty much to the same directory. So whenever I build a real container, a lot of this stuff won't be in there. But like I mentioned, if you're doing like PDF generator and you need to make sure that certain fonts get installed on the Linux image in a certain location, being able to navigate this file system is super useful in that container, because oftentimes you're trying to troubleshoot whether or not it got installed or if it got installed in the wrong place and that sort of thing. So this Files tab is super useful. You can also see the logs, and this is going to look pretty similar to what it was when I opened it up in .NET, ASP.NET. Any ports that are exposed using Docker, you can click on these links. It'll open the browser for you. Some of the environment variables, not all of them, which is kind of odd, and I'll show you. You can also terminal into the container. So here's a terminal in the container, and see these environment variables down here. If I say print env, print, it would help if I spell it right. You can see there's a few additional environment variables in the container that aren't surfaced in this tool, but a lot of them are really the running environment specifically. So it's not that big of a deal, but they're not all surfaced here. But that just goes to show that you can terminal into it and do whatever you need to do, which is another very useful aspect to it. You can attach to a process running in a container if you need to. You can remove the container, you can stop the container, you can look at all the images installed on your machine, and then these are just the layers. That's the highlights of the container tools. And well, let me show you this other one. So once you get a container, you're going to then need to get into a registry. And if you don't have your DevOps pipeline set up yet, you may just want to get it out, test things out, and to prove the point. So another thing the container tools do is they add the ability to deploy to a container registry. So part of the deployment for a project that's been added, had the Docker files, the Docker tools added to it, is you can publish to a container registry. So if you walk through this, you can go to Docker Hub, you can go to Azure Container Registry or some other Docker container registry, and then it'll publish that out on your registry. It'll rebuild the image and then push it out. So that's also another useful tool that they added to your tool set. There's an additional tool that we'll get back to this this project later on in the talk. So any questions so far?
We have one question from Andrew.
Okay, so what kind of skill set list or skills or things do you need to manage this? Do you recommend a job role or person, maybe idea for someone moving from on-prem to cloud? So far with what we've covered, it's going to be someone who sees the value of containerizing their application. This could be a developer. It does seem like in most cases it's the developer that's doing this portion, because it's their application that's getting put in the container, and they can test it running on Docker on their system. This wouldn't necessarily be a DevOps person or an ops person. It would definitely be a developer that's containerizing their application. Now, as we get to the tooling later, the DevOps pipelines, that could be a DevOps person or an ops person that manages the DevOps pipelines. But they're going to need to closely interact with the developer as to what needs to be built, any special stuff that needs to be, any special sauce in the container and that sort of thing. So you've been looking for, okay. Yeah. So DevOps people could play a large role, but oftentimes it's like devs. And my experience is devs do kind of tend to need to be full stack no matter what, even if they do specialize. But different shops are different. So yeah, devs is my experience. DevOps people will definitely help with the same sort of thing, but into the Kubernetes cluster itself. I have two questions for you. I thought you mentioned Docker is cross-platform. Then why do you have to choose OS between Windows and Linux? Good question. Okay. Why would you use Windows OS if image is so much larger than the Linux one? Okay, so good questions, very good questions. So with the the Docker image, having to choose the base image flavor, whether it's Linux or Windows. It used to only be Linux. You didn't have a Windows choice, but then Windows became available, and now you have to choose between the two. The difference is it's basically they don't expose the same features in the OS that's being exposed. So containers really virtualize the OS. So if some features in Windows don't exist in Linux or vice versa, they can't make a container actually cross-platform. Docker is, because Docker runs on Linux, runs on Mac, runs on Windows. The Docker engine itself, but the Docker engine itself also has two modes. Let me see. Can you guys see my tray when I open it? Because I'm not. Okay, cool. So if you right click on it, you'll see that you have to switch to Windows containers. And then once I switch to Windows containers, it will then ask me if I want to switch to Linux containers. So it gives you the opposite option. It's just a switch. But you do have to choose which mode you want to be working in. It's all because the underlying operating systems are so different. And you'll see this also with Windows subsystem for Linux, the WSL, or this new terminal, Windows terminal. It also has moved backwards because of the same problem. Before, the WSL version 1 tried to do that, mapping Windows and Linux. Actually, it mapped Linux calls to Windows calls so that they would more or less have a Linux translation layer between the two. And they found that it just didn't work. It wasn't optimal. So with the WSL2, it actually uses a container under the covers of a real OS, a real Linux operating system running. So they realized that it was way too slow. It was a very maintenance, or I should say, if Linux pushed out a new fix, well, then that means they now had to add that additional call in that they didn't have to manage before, because they were doing that translation to make the operating systems answer the same calls. So we still have that difference. They definitely aren't equal. So I think that answers both of them.
Yeah, I think I got it.
Okay, so there are really good reasons to use Windows over Linux. Linux by far is going to be your fastest, cheapest option. Not everything runs on Linux though. It's great to be able to write C# code, and now with .NET 5 you can do your whole .NET framework, C# code, compile it and run it on Linux. But there's old .NET code that won't run on Linux, so it's got to run on a Windows Server image or one of the smaller Windows Server images, and those suckers are big and they take a lot more resources than Linux just because it's Windows. But okay, good questions, very good questions. Okay, so Kubernetes. So Kubernetes solves the problem that you start to get as soon as you have multiple containers running. So, like what I just showed you, we got a container up and running in my dev environment, pretty easy. And I could easily run that in Docker on my machine or on a server. But there's other things that you need to handle when you've got a production application going. It's like, what happens if the container goes down? Who's watching that? So if you need to restart it, okay. What if you want multiple versions so that you can do a load balancing and spread the load across multiple instances for scalability? How are you going to do that? So these sorts of things that you start to get whenever you realize what it takes to be production worthy is where a container orchestrator comes in. And that's really a system that's designed to provide these 5 chunks of functionality here. So it first and foremost is a clustering technology that will take multiple VMs and pretty much provide you this pool of compute that you can run your Docker containers on, or containers. And you might want to specify some rules. Well, you don't want this, back up. Say you have a site that you want 3 instances always running for high availability, and you're going to provide a load balancing across them. And you may want some rules and say, okay, well, I know I have 3 VMs behind the scenes. I want to make sure that only one is running on a specific node. So I want 3 of them running, but I want them spread across each nodes. I don't, in case one node goes down, the site will still be up. Rules like that are production rules. Those are things you will want to do in production. And that's one of the things that an orchestrator will do for you, which that gives you the ability to do high availability because you're able to have multiple instances running and a load balancing on top. Health monitoring is important because if a container goes down, it's like if a tree falls in the wood, who hears it? Well, if a container dies, who's going to know that that container died to start another one or, troubleshoot what's going on? So you need some health monitoring in there. And along with health monitoring goes a life cycle. So when you start up a container, you want it to be able to go through certain life cycles because you may have, maybe you have an application that really needs to be really performant. So the first thing it does when it starts up is it pulls a lot of data and caches it locally so that it can behave really quick. And you don't want it to actually be available to any traffic until that cache is ready to be used. Well, then you need the ability to tie into a life cycle so that is the cache ready yet? Is it ready to be put behind a load balancer? And those sorts of things. So you need a life cycle to go along with these containers running, not just on or off. You need a life cycle. And of course, when you have more than one of anything, you need to be able to communicate between the two. And it doesn't do you any good if you can't communicate in and out of the cluster. So you want to go in between the pods or containers in the cluster, and you want to be able to go in and out of the cluster. And there's a lot of stuff that goes with these 5 pieces of functionality, but these are the main pieces that a container orchestrator is going to provide for you, and that's what Kubernetes is. It's a container orchestrator. Some of the highlights, if you look at the Kubernetes website, it's going to say that it's the system that provides scheduling for compute. So, like I said, it's a clustering technology. So this scheduler, one of the presentations that I've seen says that the scheduler is like a maitre d' when you go to a restaurant. You walk up to the little desk and he asks you how many is in your party and he finds you a table to sit at. And that's what this scheduler does, is it will look at what resources your application is requiring, and then it will look across the compute nodes to see where you would fit into the mix. And whether, if you can't, it will then go into a pending state and not get you scheduled. And there are other things that could be done behind the scenes to free up room so that you can be scheduled. But that's what the scheduler does, is it finds a place for that pod to run when it shows up on the Kubernetes doorstep. It's self-healing, so it has that health monitoring. If a pod goes down and it is unhealthy, it will shoot it and then bring a new one up. That's one of the huge changes. So myself, coming from pre.NET to .NET, and all of the deployments being file-based, IIS for so many years, you didn't blow away the VM, you fixed the thing. When something went down, you fixed it. You remoted into the machine. If you were an automated shop, well, you had a DevOps button that you would push, and you'd fix the code, and then it would push the new bytes out. But it would be file-based, going out, patching that running instance. The biggest difference with container applications are you don't fix the container, you shoot it and bring up a new one. So if you have a bug, you would fix the container, push out the new container, and then bring it up in your environment. Kubernetes, if a container's down, it assumes that it's a transient issue, kills it, starts a new container. If that new container fails, it will try it again. There are definitely a lot of settings that you can set in there as to how many retries, what happens when it fails, does it try to restart it? There are all kinds of bells and whistles there, but self-healing is a huge point. Service discovery, load balancing, that's just the networking stuff that has to, if any framework is going to give you the ability to run multiple containers and give you a production-worthy environment, it's got to have the ability to discover services and do load balancing. Horizontal scaling is the most natural scaling when it comes to containers, because it's not easy. Once a container gets baked and running, you can't really say, oh, no, I said I wanted to have this much of a CPU, but now I need to change that and make it more. there are things you can do, but it's a much better if your application horizontally scales. It's like if it's starting to get under a lot of CPU usage, it can spin up another one. So you can set rules and say, hey, whenever this web server gets to 70% CPU or so much RAM or some external metrics that you can set it on, spin up another instance. And then it can just continue to stamp out. And of course, you can put rules around that as well. But it has the ability to do horizontal scaling, and it can spin up additional instances whenever thresholds get hit. Very, very useful. Automated rollouts and rollbacks, also really useful. I mean, we do have our DevOps pipelines that allow us to do that as well. But in Kubernetes, you know, it's right there. It can roll back to the previous version. And the cool thing about containers is it's just that name of the container, and it will, if it already has that old container locally, it'll just start it up. It doesn't need to pull any new bytes down. So, you know, comparing to IIS application, where if we needed to roll back and didn't use any of the web deploy features, we would have to redeploy that old version. So we would have to, again, push all those files across the wire. But with, excuse me, but with containers, you don't have that problem. Everything's already containerized, stuck in that zip file system, and you only have to tell Kubernetes which one to look at, and it will roll out, roll back. You can set a lot of parameters around that too. The default is it will do a rolling update. So say you have 3 instances, and you do a deployment rollout, it will bring up a new instance of your new version. And then once it's up and healthy, it'll bring down one of the old ones, and it'll bring up another new one until it's replaced all the instances that you wanted running. But the caveat to that is that works really well if you have more than one instance running. So if you have 2 running, that's kind of what it's designed for, high availability scenarios. If you only have 1 running always in production, then you're kind of going against what all of the good feature set is built towards. So you could have some downtime if you just spin up that one and bring that other one down. There could be a window there. But if you had 2 coming up, you know, you would always have 1 up and running. Volume management, that's just your storage. Every system is going to need some ability to have some secrets and configure management. So Kubernetes does that as well. So a little bit about the architecture. Don't want to get into this too much. It's basically made up of 2 types of nodes. This is the master node. It provides all of your overhead, I guess. So it's got the API server, that is your communication in and out of the cluster logic. Your controller manager, that's the one that makes things happen. So everything that's done in Kubernetes is pretty much done by a controller. The controller manager is the one that decides which controller needs to actually be doing the work for the scenario that's come up. You know, did a job show up that needs to be run? Did a cron job trigger and need to be kicked off? Did a new pod show up and need to be scheduled? So the controller manager is the one that really drives the logic. The scheduler is the one that talks to the worker nodes to determine where the new workload can go. And etcd is just the key value storage that the state of the system is stored in. The worker nodes, that's what you'll see you actually manage in Azure Kubernetes Service. You don't see the master so much. You interact with the API server, and you can get a lot of the logs of things that are happening, but you don't see the other components. You basically only focus on the worker nodes. The worker nodes are connected to the master with this thing called a kubelet. And the kube proxy, that is the one that deals with the networking in and out. So this is the one, the kubelet is the one that connects you to the master, and the kube proxy is the one that deals with the networking. Docker is here in the image. It's the better terminology for this would really be just a container runtime, because it's a pluggable piece you can put in different container runtimes. Actually, Docker is being deprecated from Kubernetes 1.20. And that may surprise some people, but when you start to look into it, Docker is being removed, but that's because Docker is a lot more than just a container runtime. Its container runtime, container D, is still going to be there. So they've just narrowed the surface of what they're using out of Docker, which is a great thing. So Docker deals with containers, but Kubernetes deals with pods, and a pod can have more or less connect multiple containers. So let's talk a little bit about these. So some of the common objects. So everything in Kubernetes is typically referred to as an object or a resource. These are the most common you're going to see, for example, for a website or a microservices environment. The pod, that's the most basic level of execution. So if anything's running in, I should say, this is not completely true, but for the scenario where you want to run your application in Kubernetes, it's going to be running as a pod. So this is going to be wrapping your container with some additional metadata, and that's your pod. There are scenarios where you want multiple containers running. Oftentimes it's like a service mesh, which I won't be able to get into, or a translator, maybe, or a logger. A logger is also a common scenario. Maybe your application does a lot of work and you want another container to more or less pull the logs out of your application, deal with sticking them in storage. That way your container could kind of plug and play, and your logger could be more general purpose that you could also use in other pods. So there are scenarios where you'd want more than one container, but when you're starting out, it's just going to be one container, one pod. So it's container plus metadata about what that is. A deployment is a layer on top of that pod. So the deployment, if you're utilizing a deployment object, it uses things under the covers. It's going to utilize a replica set. A replica set is it's a controller in Kubernetes, and its only job is to keep the desired state of the system that you've said. If you said you only want one instance running, it will make sure that one instance is running. So, and the instance in this case is going to be pods. So if you say, I have a deployment of this web app and I only want one instance running, but you want to restart that website, well, there's no restarting in Kubernetes. You kill the pod. And then the replica set sees, oh, hey, it's now 0, start a new one. So you don't have to say, oh, I need to do multiple commands to remove an old pod and put a new one in. You remove the pod, Kubernetes just spins up a new one. Same thing if you have 2 or 3 instances. Say one goes down, it would then say, oh, well, there's now only 2. They want 3, so I need to start another one. So the replica set is the controller behind the scenes that is watching the state of the system to make sure that the number is running that you want to be running. So it keeps the desired state going. Another part of deployment is the ability to do the updates, the rolling updates. And there are a couple of different flavors of rolling updates. One is the one or I should say there's a couple ways to do deployments of your application out. One is the rolling update. Another one would be where it will bring a new version up. If you have 3 instances, it will bring 3 new instances up and then take all your other one down. So there's different flavors of the update and capability, but that's all wrapped in deployment and gives you this extra functionality on top of just a pod. Because you can just spin up a pod. It's pretty much the equivalent of just bringing up a container in Docker. It doesn't do a lot for you. The deployment, you bring up a deployment and you tell it what image to do it, and it manages bringing up the pods, the replica set. It manages that stuff for you. The service is the layer above the deployment, because the thing is, if you're doing high availability and you say have 3 instances running, you want one endpoint to go to so that it can then balance across those 3. You don't want to handle the logic of going across those 3. And if one goes down and the replica set brings up another one, you need something that's going to now know what that new IP address is of that new pod. That's what the service does for you. It connects the dots of what the deployment does for you. And then, of course, there's multiple types of services so that you can surface the IP at different levels. But the ingress is the piece that gives you the external access. So it sits on the edge of your cluster and is integrated with your cloud provider. So in the case of Azure, it's going to interact with an Azure load balancer or an app gateway. So the ingress is really that gateway to the external world outside of your cluster. Okay, so any questions before we get moving here? I see a few here. However, all node 0 will be Linux, and then 1N would be Windows. Yeah, in AKS, that's how it works. It works with node pools, so you're right on that one. It makes it easier for high availability configuration. Okay, it makes it okay. During updates such as rolling, does it have a mechanism to drain running pods before deleting them? For example, active. Yes, it does. So it will remove it from the load balancer and let those connections die out. There's also a life cycle of a pod. So if you have a container that really a container in this case, that needs to do some cleanup before you want the plug pulled on the pod, you can do that too. You can specify that certain things need to be done before your pod says, okay, I'm all right to shoot at this point. So there are definitely things you can do on that. Okay, so Kubernetes Conformance. This is the reason, in my opinion, why Kubernetes in the cloud has really taken off. So there's this idea of Kubernetes Conformance, and what that means is, say the cloud provider, in this case Azure Kubernetes Service, meets a specific level of feature implementation that other conformant Kubernetes implementations meet. So if you have your application running in Azure Kubernetes, then you can, with less effort, move it to another conformant implementation versus, say, a custom orchestrator. It could be completely it may not even exist in another cloud provider. So the fact that Kubernetes has this standard set of features that are available, and if it's certified Kubernetes, then it's not completely effortless to move from one environment to the other, because like I mentioned on the last slide, there are pieces that do interact with the cloud infrastructure, like the ingress in that case. It's a load balancer. The other cloud providers are going to have the same thing, and the networking layer is almost always, I would say, is always implemented also by the cloud provider because it's their network. It's got to integrate with theirs, and that's just a pluggable piece in the Kubernetes infrastructure is the networking. So certain things are going to be specific to a cloud provider, but the fact that they're conformant means that their implementation is pretty much the same as yours in another cloud provider. So that's a key thing. So if you have Docker Desktop installed, you have a version of Kubernetes running. So let me show you that. I have it open here. So Docker Desktop, if you go to the settings of the gear here, you'll see that on this tab, there's a Kubernetes. You can enable Kubernetes and it will have a local cluster running on your machine, which is really cool. It's only one node, so you can't do multi-node stuff. And granted, it's on your machine, so you may not have the ability to do ingress and a lot of other things, but it allows you to test your code relatively easily on your local machine. So we've got a question here. What kinds of factors determine how many containers run in a pod? It really depends on what your application needs. It goes with life cycle. So if you have a web application, say, and maybe it uses API, and maybe in the IIS world, you had both of those running on the same machine, you wouldn't want them really in the same pod, unless there's a security need where you want to make sure that's only ever available to local host, or for maybe performance or some reason like that. You would want those to be separate pods, because if you needed to update, say, the API and not the website, you wouldn't want to have to bring them both down. So you really want it to be granular in your system sense. Some of the most common scenarios for multi-containers pods are loggers, adapters, something that needs to, uh, logger and adapters are actually often pretty similar. There's another pattern called an ambassador pattern, where it's actually the opposite of a adapter, but there's always specific scenarios where you would want a container running alongside another container. It's not very common. Most likely, if the logic is so related that you're thinking about putting them beside each other, you would most likely just have them in the same container, not multiple containers running in the same pod. You'd want them separately. Typically, the multiple containers scenarios I see are injected containers, like a service mesh will inject a container into the pod whenever you deploy it. So there's this thing, there are hooks in Kubernetes that will allow you to inject things when they're being created, and service meshes are good at that. There's a few other instances, but logging is the only scenario that I've seen where it's not something that's being injected. I have a question. Price-wise, when it makes sense from app service containers to AKS. App service. Oh, okay. So app service containers. So price-wise, that's a different story. I wouldn't necessarily say it's a price thing. We'd have to look at that. But it's more whenever you have more than one app, it's a lot easier to maintain them when they're all in Kubernetes versus having to maintain multiple app services. You'd have to kind of price out your scenario to see how it would work out for you, because hardware is also different, because some applications need more RAM than they do CPU. Some need more CPU than they do RAM. So it is kind of a Goldilocks that you have to figure out what works best for your application. And then, of course, once you figure that out on VMs, you could then understand more of whether or not app services is more relevant versus, if you're just running one container versus a cluster of containers. So it's all case by case basis. If you have a website that uses microservices behind the scenes, I would say Kubernetes just makes more sense. You may still want to use app service to front the microservices in the back. That's perfectly okay too. So it is totally case by case basis. No clear answer on that one. Okay, so Helm. Helm is a package manager for getting your applications deployed into Kubernetes. When you look at Helm and you see presentations at Helm, in my opinion, it's presented in a way that doesn't really highlight its value for custom development. So for instance, a package manager in this case means, say, a package like WordPress. Maybe I want to deploy WordPress in my cluster. Helm has a chart out there for WordPress, and a WordPress is typically a database and a website that's written in a technology that I don't develop in, so I wouldn't necessarily want to configure it myself. But there's a WordPress chart out there, and the charts are what they the chart is a term that they use for package in Helm. I can install a WordPress environment which will bring up the database and the web application running in containers in my cluster with one line in the command prompt using Helm, because it will pull down the chart and do all the configuration, bring it up in the cluster itself. So that's how it's usually presented. So give you the idea, hey, it is a package manager. You can deploy these well-known packages in your cluster. That's cool, but from what I've found for people implementing enterprise software, Helm is more powerful as a templating engine for your application. For instance, I've found you often only have a few different flavors of applications. Say you're a shop where you have certain websites that are ASP.NET Core, and you have services that are really web APIs, and they really have the same deployment scenario. You may only need one chart for those web apps, even though you may have 50 of those web APIs. You may only need one chart, and then you specify the different feature flags that you would want to change when you deploy it, but you may only need one chart. And you can deploy your application in one line and change those flags as you need. It's kind of an abstract sense, but we'll see it here in action. So Azure DevOps. Before we get into that, let me show you Helm. So if I go back to Visual Studio here, so this was the template that we Dockerized. Very simple application. Another thing that, so this doesn't come right with the container tools. You have to have it on the slide deck all the way up here. You have to have the Azure development features installed of Visual Studio to get the Helm chart creation. So let me show you Helm chart creation. We just talked about Helm. So simple web app. I showed you the creation of a Docker file that was simple enough to get this web application built. Let me show you creating. So I go to Container Orchestrator support, and I say, oh man, why is this not here? What did I do wrong? Oh well. Let me show you another app here. So this application is the same thing before. I'm not going to debug what step I took wrong on the other one. It may be the wrong version of the OS. I'm not sure. So if you right-click on this and add Container Orchestrator support, it gives you multiple options. One's a Docker Compose and one's Container Helm. So if I choose this and I hit OK, what it's going to do is it's going to create a charts directory. And in this charts directory is a Helm chart that will install this web application in Kubernetes for us. So if you look at what's contained in here, you'll see there are two levels of things. And the most powerful piece of Helm, in my opinion, especially for enterprise development, is this right here, this capability. This is a templatized YAML file. So if you look through here, you can see, let's look at the image. So here's image. So the image is going to take this piece of information, values image.repository, and concatenate it with image.tag, and it's going to create the output of the image whenever it transforms this this template to push my application out to Kubernetes. So let's prove that. So this is the one place I will drop to the command line. So this is web application 2. Let's build this. So ls, that's web 2. So cd web app 2 ls. So I'm in Windows. I'm in WSL2 or Windows Terminal, I guess. This is a Ubuntu version. So I want to go to the charts directory. So the ls charts. So here is the chart, web application 2. Let me show you. Yeah, so I've got the Docker desktop running. So okay, so I have an alias set. For those of you who are new to Linux, which I was for the longest time, kubectl is the command that you have to type over and over and over. It's a lot easier if you just say alias k equals kubectl. So you can now just say k. I want to see what context I have. So basically, what cluster is my command line looking at? And we'll get a little bit more into the command line a little later, how to set it up. Config current context. So my current context is my Docker desktop. So that's the cluster that I'm looking at. And Helm is going to follow the same tools that my kube config is currently pointed at. So if I say Helm install web app, well, I called this one 2. Let's call it. I'm not sure if I have it. So let's be safe and call it web app 9 because this is just a name that's going to use. And I want to use the chart in the charts file. Chart web. Hold on, let me check this first. cd charts. Okay, so yeah, web application 2 is lowercase, not uppercase. There's no casing in. So I want to go Helm install web app 9 or 0 would work too. Dot web application 2. So what this is going to do is it's going to take, and let me just run this. Oh, what did I do wrong now? The web application, I can't type for some reason. Okay, so that's all it took. It's installed in the cluster now. So if I say get all, you can see we have web application 2 pod running, we have a web application 2 service running, and we have the deployment running. And it's only been running for 8 seconds. So this was just deployed, and all it took was that one command. But the cool thing, and this is where it becomes useful in the DevOps pipelines, is, I did the Helm install for what was out of the box, but here, let me show you. So let's do an upgrade. Sorry, handicapped here. Upgrade. And let me show you this. So this is the template. It's plugging these values in for the image. See that the tag is here. I'll substitute the tab. So the way that Helm works is there's 2 levels. One is templates. That's where all your templatized YAML is. The next level is where the default values are. So this created the default values for what's in this this build. So it used the tag stable. So let's change what's deployed to use a different tag, say latest, without changing the file. So this is where the DevOps stuff comes in useful, or Helm comes in useful with the DevOps. So I'm going to do the same exact thing. I want to upgrade that. I don't need the chart anymore because it's already deployed. I want to say set image tag equals latest. So upgrade. So I guess I do need the chart. Upgrade. Dot whack web application 2. Okay, so it upgraded it. So now if I say get, actually, let's just do it quickly. Deploy get why this should show what the container that is deployed. So this is the deployment. Like I said, the deployment's the one that kind of manages the pods, and this is the image that it's working with now. It's using the latest, where before it used the stable. So all I had to do is run that one line. So in our DevOps pipeline, you can change that. You go into QA, well, you can change it to the version you want deployed to QA. Piece of cake. That is where Helm really comes light, for my opinion. With enterprise development, it's that ability to deploy your applications. So Azure DevOps. Now this is going to be the way to get your code into Kubernetes, and it'll either use kubectl or Helm to do so. And here's sort of the chart that it kind of an interesting one here. Got Bill moving some stuff. I just muted you, Bill. So I just lost my spot. Okay, so this is the flow. This has to do with debugging. There's this thing called Azure Dev Spaces, which allows you to interact with an existing cluster but debug locally. I'll ignore that for right now. But this is where the pipeline comes into play. So the developer works on a source, checks it into the repo. The pipeline kicks off, builds the image, sticks it in the container registry. And then the pipeline utilizes a chart to then deploy to the Kubernetes cluster. So all of this past the source control can completely be automated. So all the developer has to do is check his code in, and within minutes it can end up in the cluster. So let's look at how you would do that. You're going to use either kubectl or Helm, and you'll see an example of both here. And I'll also show you how to get this running for yourself, so you have it for reference later. So DevOps, so in your Azure portal, what you want to do is do a search for a DevOps and find the DevOps starter. That's what I want to show an example of, and this is really useful to give you more or less a reference implementation that you can look at and reference to build your own pipelines. So I want to do .NET next, ASP.NET Core, Kubernetes. As you can see, there were a lot of different choices. We're just using it to look at Kubernetes tonight. So we're going to say Azure. Not taking cool. Okay, so I don't really care where it goes. This is just a demo. One thing you'll want to do when you set this up yourself is you're going to want to go to the additional settings and change this node count to 1. If you want 3, that's great, but you're going to be paying for 3 VMs to run, and you can change that later. So I always set it to 1 first. You can choose the flavor, or I should say the version of Kubernetes that you want. I'll go with the latest. This is the general information. This is the container registry that it's going to create for me. I'm going to put it in the same data center. So East US, I'll stick with the standard machine. If you wanted to change the size, so maybe you have some code that's more memory intensive, you can change the machine here, but I'm going to leave it and then let it go. So this actually amazingly doesn't take too long, but let me see if there are any questions. Any questions? Sound test. Yeah. So what this is doing right now is it's going to a GitHub. The source code for all these little sample apps are in GitHub. So it's going to GitHub, cloning that GitHub repo, and then it's creating an Azure repo. So a place to clone that source code, then it's creating a pipeline to do the build, and then it's creating a release pipeline to do the release to the cluster. And see, it's done already. So this is now I have this reference implementation. You can see right here, right now, nothing's deployed. It'll get to that. But what we have here, and I'll start kind of from the beginning for those of you who aren't super familiar with Azure DevOps. So we'll start at the top. This is the Git repo. I see your questions. I'll get to them. There's definitely a lot of help, but really you'll see that this little starter thing, once you get it going, then it'll actually give you more information to search for more detailed explanations versus a tutorial. But there is one, and I do have a link to it in my slide deck that walks you through how to do this. There are multiple ways, of course, but this is one way. So this is the repo. So this is just the file system on the GitHub repo, or it's not GitHub, it's Git repo in Azure DevOps. So there are a few things in here other than source code. Let me show you. So first of all, this thing called ARM templates. So this is your infrastructure as code. On my slide, I had a little symbol for Terraform. This could also be done by Terraform. It's more or less the stuff that's going to create the infrastructure. So there's also another piece to that. Here, there's not another piece of that. This is the web application. And then here's the Helm chart to install the web application. So this is an example or a reference implementation of how you would create a DevOps pipeline and the Helm charts to put a simple application out into Kubernetes. So this is just source code, only files. So now the build pipeline. So this is a build pipeline. There are two pipelines. This is the build pipeline and this is the release pipeline, the little rocket ship here. So the build pipelines, let's look at what this looks like. If you hit edit, it shows you the steps. Things to keep in mind with the build pipeline, you can have triggers turned on. So these are under the trigger tab. By default, this reference implementation is continuous integration. So it's going to automatically build it and release it. So it's CI and CD automated. So if you didn't want it to do a build automatically when someone merged the code in with the master branch in this case, you would not check this. You would uncheck this. If you want to set a schedule or whatever to do the build, you can do that here under the triggers. But by default, this is the thing that makes all of these boxes start to turn green. on this. So the one that I did, was it BA demo? I've done a few of these, in case you haven't noticed. Oh yeah, it's not bad demo. This is a different one. But all of these, it will end up releasing the thing and putting it out into Kubernetes. By the time I get through this, it should be deployed. So that's what makes these steps continue to go as I'm talking. So here are the tasks. So the pipeline, you need to determine, is it a Linux? Are you building on a Linux machine or a Windows machine? This is where you would choose those. This is just setting the source to pull in order to do the build, and you can change your repos, your branches, and all that stuff here. And then these are the individual steps. Since this is an example of a containerized application, they've added in this step for infrastructure as code. So this will actually create a container registry. So all it does is run an ARM template that's in the source code under the ARM area that we looked at. So this here is the ARM template to create it. So they've put that, let me actually step this out. They've put that in the build so that if the container registry isn't there yet, it will actually create the container registry, and then it builds the source code. So here's where it runs the Docker build, and then it actually build an image. This connects it to the container registry. So this connects it to your Azure resources. This runs the Docker build. And then this is some of the stuff that needs to go to the command line to create the image, to output it. The next step is the one that actually pushes that image to the Docker registry. The way that these are structured is the Azure connection is at the top. So what Azure resources it's connected to are at the top, and then the utility information is at the bottom. So this is the step one, build it. Step two, push it. Then this brings down the Helm tool because it's not on the build machine natively. And then this builds a package, which means it takes that chart that we looked at the directory, builds a Helm package and puts it onto a staging directory. And then it copies the other additional ARM templates because the release will actually create the cluster if it doesn't exist. So that's what the other ARM templates are for. And then it pushes those artifacts that it just copied, which is only the Helm template and those ARM templates, to a staging directory that is kind of the data handoff for the release build. And you can see these. So if you go to the build and you click on this, and click on the actual individual build, you can see some stats and you can continue into it and look at the logs if you want. But this right here, this is where you can see actually what has been published. So you can see it's very small. We've got what, 10K here for the actual data handoff to the release to do this cluster build and deployment of a web app. This is the Helm template. This is the ARM template that's used to create. And see, if you had another pipeline that actually did your infrastructure build, you wouldn't even have these in here. You would only have the Helm template. So this is all that's needed to pass over, and that's solely due to the fact that your application was built, put into a container, and now that container is actually in a repository. So if I go to the Azure portal and go to the container registry, this again is where the question of what was the name. Doesn't matter, these are all the same. So if you go into here and go to repositories, you would then see the container for your application here. Of course, I chose one where it doesn't have a container, but this one has one. So here's a container. And then this would be the application that was actually built. So back to the pipeline. So yep, so that's the source. This is the pipeline. So that's the build. At this point, the build has created everything that is needed to deploy, but hasn't deployed it. The release is the one that does the deployment. So and it's currently doing the deployment. So let's look and see what this does. This is the artifact. So this is the starting point for what the release needs to do. If you look at this drop, if you click on the artifacts, you would then be able to get a hyperlink to go back to the build that is the source for this, and then you could look at the individual artifacts. So that's nice that they have this hyperlink, because oftentimes you need to see once a build goes out, is like, did it deploy the right one? So this is the starting point. These are the steps. You can have multiple of these, but this is the release step. Let's go to, this is all infrastructure stuff here. It's going to bring up the cluster. This is just extracting the key for the AI, which is application insights, to be used later on. These two steps are only used the first time, because once the namespace in the cluster, so this is Azure infrastructure setup, and these are cluster setup. So your application needs these. The pull secret is what the cluster is going to use to pull that image out of the registry. And then here it installs the Helm tool, and it runs that Helm install. So when I ran the Helm install on my command line, I set the image tag, but you can see here out of the box, this reference implementation sets some additional ones. It sets the repository, so this is the image name, the tag, and then this is the application key. So this is a good instance where this is going to be different for each environment that you deploy your application to. So the way that it uses these, so it uses some variables and passing stuff in and around this tool that you can completely reverse engineer. Good examples of how you would actually do this stuff in production, and this is going to be different for different repos. So this Helm upgrade is going to deploy that sample web application out to the cluster. So let's see if this is BOS Azure 1. So let's see if we can actually find the correct DevOps now. So let's go home, starter. There we go. So this is the one that is working on deploying. Okay, so it's deployed. So here's the sample web app. If I click on this link, this is the sample. So this is the sample or the reference implementation, very simple ASP.NET core web app, and it must have just went out because it's taken a moment to come up. All right, so we'll come back to that in just a second. So that's the public IP that it has exposed an endpoint to and all of this stuff. Oh, great. We can get it working. This is the Kubernetes cluster that it spun up from that ARM template. And eventually some data will start coming in app insights down here. So if we go to the cluster, we can go here. So you can see the application came up. It was just transitioning over. So the cluster is now deployed, and this we'll get into in the next demo. But that's the reference implementation. So what it did is it created the replo, and it connected all the dots in a realistic CI/CD pipeline that you could actually use in production to get an application up and running on the public internet. So that's a really super useful starter kit for a reference implementation. So let me get back to my slide deck. Any questions so far before we finally get into Kubernetes, Azure Kubernetes Service? I mean, we've touched on a lot of the stuff that you really need to do Kubernetes in production. So now we actually go into the hosting environment, which is the Kubernetes service. Okay, cool. So I'll keep going here. So Kubernetes service. So Kubernetes on, so AKS, it's a managed service, which means they manage some of the infrastructure for you. Not all of it, but some of it. You don't have to pay for the management control plane. So back in this diagram here, Microsoft manages the Kubernetes master for you. So what does that mean for you? Means this thing that would have to be on a highly available set of virtual machines, because you would want to make sure that there's at least 2 to 3 versions running, because if one went down, you want to make sure that it's still up. So it's going to be highly available. And this etcd data store also needs to be highly available. So they take care of managing that stuff for you. You don't need to. You worry about the worker nodes and not the master stuff. And that means you don't pay for the master stuff either. You don't even pay for a portion of them. I believe in Amazon and Google, you have to pay for a portion of the master plane up and running. So you only pay for the worker nodes, which is kind of cool. So it's easily scalable. So you can scale your instances out, and I'll show you this here in a second. And it's also a Kubernetes conformant. And there's also this idea of a virtual node, which works with Azure Kubernetes instances or container instances, which more or less allows you to have a node that, because when you have a node, it's backed by a VM. So there's only so many CPUs, only so much RAM on that VPN or VM, sorry. So if you need more, you have to spin up another node. But with Azure Container Instances, that you can treat as just this endless pool of compute resources and just keep creating them. The caveat of that is they can be slow to start because it's in an external environment from your cluster. It's not on the VMs that your cluster's on. So let's go through the portal here, which is where we left off. So this is Azure Kubernetes Service landing page. Shows you your typical information for the resource at a high level. So it shows you some information about your networking. It shows you, and where the API is for interacting with the cluster. It shows you the version that it's on, the type of network. There are two flavors of network. One is KubeNet, and the other is Azure CNI. For production, you're most likely going to use the Azure CNI, but that starter kit uses the KubeNet. This is the node count. Right now, I've only got 1 node, which is cool. Your subscription stuff, which you don't need to know, and some capabilities. So this is just highlighting stuff. So let's go through here. Let's see what's going to be the best place to start. So let's look at the node pools. So AKS works in node pools. What we created when we created the cluster is it's a system node pool, if you will. That means that this is going to be the minimal set. So you have this node size, which you can't change. You can create additional node pools. So say you find that you need more memory than what you initially created. What you can do is create another node pool with that larger set of VMs. And once you create that second one, you can then remove this one if you need to. Or you can create multiple different node pools. And you can create a node pool that's a Windows OS. So you can create different compute profiles, if you will, in different node pools, and then treat that as part of your compute power, if you will. If you want to scale, scaling is here, I believe. So we go scale. This is where I can ratchet it up. So say I want, 5 machines. I can change it to 5 and I hit apply, and it can just start stamping out additional nodes. It will take a few minutes for the VMs to come up and then the Kubernetes to put them in the rotation for the compute pool. So it will take a little bit of time. Okay, so that's how you could scale out your number of nodes, because the ability of compute that you have for your application is going to depend on how many underlying nodes you have. Cluster configuration, this is the ability. So once you have a version to upgrade to, you can upgrade it here. Scaling has been moved to the app pool, so it's no good. Networking, just information. Typically, you're going to have it on your virtual network for your company. You can also put it in a private. So one caveat to this: if you do go with a private cluster, you're going to also have so you get all the security goodness of the fact knowing that everything is behind your VNet. But you also get the caveat that you need to know the workarounds for that. So I showed you the Azure DevOps. Azure DevOps can't deploy inside of your virtual network. So you'll have to look into hosting the agents inside of your virtual network and do all of that work. So you kind of, you get a lot more security, or I should say you get more security, but you will have to do additional workarounds in order to get things in and out of that network. So that's something to keep in mind. If you just click on the ability to do the private cluster, you could shoot yourself in the foot until you figure out how to work around it. Deployment center, this ties into the release side. It's great for informational purposes or finding out what's released. It's not always used. Policy allows you to tie into policy to set a lot of things around Kubernetes. You definitely want to dig into that. It's like, for instance, say you're moving out to production, and one of the security practices that people recommend is to minimize the number of container registries that your cluster will pull from. So right now we've configured the application to pull from the Azure Container Registry that the starter kit or the starter spun up for us, but I haven't limited it either. So it could also pull from Docker Hub, and by default it will pull from Docker Hub. But and when you move out to production, you want to make sure that just miscellaneous repositories aren't being reached out to and pulling images back into your cluster. That way, you know, if someone's hacked into your cluster, they can't start bringing in bit mining images and taking over the compute of your cluster. So one of the ways to do that is through Azure Policy. You can put in what registries that you'd want to minimize it to, or limit it to, I should say. Have you ever experienced a situation where not having control of the master was an issue? Yes. Anything, as with any managed control plane, sooner or later you will most likely run into the case where something needs to be rebooted. You know, it's gummed up, so you have to contact Microsoft and have them ungum it for you. That has happened. It has not happened very often. In 2 years, I think it's happened maybe twice. So it does happen. Insights, this is the container insights. This is where you can find a lot of information out about how your cluster is performing. Right now, we don't really have much running in here. But if we had a lot running in here, you'd be able to see how much CPU is being used, how much memory is being used across the cluster. And that will help you determine, you know, what size of nodes you should have, how many nodes you should have, and that sort of things. You can drill into a little bit more detail on the nodes, the different types of controllers that you have, and the different containers that you have. With the containers one, you can actually, let's see, is the web app here? The web app right here. So if I choose the web app, I should be able to look at the logs for the web app. So if I've selected it over here, and I can say, show me the container logs for the web app. So it goes in, and these are the logs that have gone out to the web app. So if it was running on the console on my machine, I would be able to see these in a terminal window. So that's the logs, which is very useful. It's really useful for jobs, cron jobs, for instance. Jobs is a way to run a pod in Kubernetes. So there's always two types of containers. One is the type that runs some logic and finishes, goes away, it's done. So you're not paying for it after it's done. And then you have the others, and the great example is a website. It needs to be up 24/7. So it not only doesn't ever return, you want it up and running all the time. So there's those two flavors, and a job is a great way to run the type that runs and goes away in Kubernetes. And a cron job is one that'll start one of those jobs on a cron job, on a cron schedule. So those are the two types. The drawback is with a cron job and jobs, especially cron jobs, because say they're running every hour, and you have a problem with it. You have limits that you can set. So you can say, just keep the logs around for the last two successful or last two failures. You won't want that number to be too large because you do pay for quite a bit of logs going in and out. And let me bring this up too, because this is important. Once you put your app out into production, or get a sizable number of pods out running, and you have the default set up for your containers, what you'll want to do is go to the the metrics. It's not metrics. It's not settings. It's not advisor either. Here, logs. I thought it used to be called metrics. Anyways, you'll want to go to logs, and then in this set, it will show you pods, view data ingestion by completed jobs. You'll want to play with these default ones because you want to see how many logs. Here we go. Billable log data per namespace, billable log data per log type. You'll want to see if you've got too many things, putting too many pieces of data into the Azure Monitor, because you get charged for every byte that gets ingested into that that data set. So you'll want to check these every now and then to make sure. One of them's got a pie chart, it's pretty slick, but you'll want to keep an eye on that, because your data ingestion can end up costing as much as your cluster. And I've seen that happen. So you want to be aware of, when you get a lot of stuff out running, how many things are you logging? Are you logging just stuff you need, or are you logging too much? So you'll want to keep an eye on that. So I just want to make sure that I'm covering what I want to cover here. So let me show you, going back to the command prompt, how to wire this up to your command prompt. I'll show you the equivalent of the Kubernetes dashboard. I won't actually show you the dashboard, and I probably won't get to the Kubernetes deployment. And then when you download the deck, you'll see that there's several resources at the end. Okay, so let's get the cluster connected to my, because I just created it. That means my terminal doesn't know anything about this. The way to do that is this button called Connect. It gives you almost all of the necessary commands. If you don't have kubectl, let me clear this. If you don't have kubectl, kubectl, kubectl installed, whatever you want to call it, you want to, once you connect to AZ, so AZ is your Azure command line interface, you'll want to run AZ AKS, what is it, install CLI? Actually, let's do help. So AZ AKS help, and it is the install CLI command. So that will download and install the kubectl and configure it for you. It won't set it up to the cluster yet. To set it up to the cluster is this next command here, this one. So if you don't know that you're using the correct account, you can copy that. Let me dock these. I'm jumping back and forth. Okay, so here, this will do the correct account because it could be on a different account. And then this get credentials, this is the one that will connect it. So I run that command, and it pulls down everything it needs and puts it into my kubeconfig. So now if I say get say config current, let's say get context. What context do I have the ability? So basically, what clusters do I have the ability to connect to? So I have several here, and you can see it's already currently connected, set the current one to the one that I just looked at. So now let's run one of these commands. Let's just run it like this. Okay. I don't need this anymore. So now that it's connected to the cluster, let's see what's in the cluster. So the way that I typically do is I just say get all. And if you do this, you might be surprised that there's not much in there. And the drawback to that really cool and useful Azure starter is that it follows the practice of putting all of the stuff in a specific namespace. And by default, it's going the kgetall, since I haven't said default it to that specific namespace, is it's only looking at the default namespace. So you have to do the show all namespaces, which the shortcut is -A. This will show you all namespaces. So we can see here's the namespace. So if I say just get all, and then only for that namespace, this is the information. This is the stuff that was deployed. And Helm also works off of namespaces. Helm ls will show you all the Helm items installed, but look, I didn't install the namespace. So if I do the namespace, it will then show me this is the Azure DevOps. So this is the Helm chart that the Azure DevOps starter created and installed. If you do like Helm get values, all right, and Azure DevOps, oops, Azure, what did I spell wrong? Oh, anyways, I guess it's not important. But if you do Helm get, there's a couple options. One is a couple options that are useful: manifest and values. Those will show you what was actually the translated version of your Helm templates. So it'll show you what Helm used to install what is on the cluster, which it can be useful if you've got problems with what was deployed. So that is the command line stuff. Now let's look at what's the equivalent of the dashboard is. And there's this application that looks like this screenshot in the back here. It's a pretty nice tool when you're learning Kubernetes. It allows you to navigate all of the objects. You can see the YAML. You can change the YAML. You can create stuff. It's called the Kubernetes dashboard. There are several other dashboards. There's even some commercial ones that you can install, web applications. There's even a mobile application that you can get to manage and navigate your Kubernetes cluster. With Azure Kubernetes Service, they stopped including that dashboard with 1.18 or 1.18 because they've added in the functionality in the portal themselves or itself. So here you can see the different namespaces. If I go into the namespace, the namespace one's kind of useless, but you can see the YAML that was used to create it. You can change it if there are any events on the object. You can see the events. If I go back, the workloads is where you would get your deployments, pods, replica sets, these different object types. So if I narrow this down to just the one that our application was in, we can see, well, I'm under deployment. There is a deployment. There are 2 pods deployed. There's 2 ready. Both are up to date. It's been up for 22 minutes. If I click on this, it will show me the contents or what it's linked to. So it's linked to these 2 different pods, some information about them, the IP. It's basically what you can see by the command line as you navigate around. If you want to see labels, that's one way you can start doing filtering for stuff. Here's the replica set that is keeping track and making sure that there are 2 pods running. You can look at the individual pods. So you can say, okay, well, here's some high-level information about it. Let me wait, this is the container. So let's look at the container. If there were 2 containers, it'd be 2 containers. The container is running. So let's look at the container. There's no well, there is a volume. It's the mount for the container. Actually, yeah. So here's the environment variables. Not much going on there. It's the app insights key that was injected. Some information, high-level information about the container. But with the breadcrumbs, you can navigate around what's in the cluster pretty well inside of the Azure portal. If you want to change something, you can go in here. So say I want to say, where's the image? The image is down here. Let's go to image and change the tag. So the tag says 34. Let's change it to 33. Hit OK and save. Okay, so you can change stuff in the portal. You can also see if there's any events. All of that stuff is pretty useful through the portal. You can also, of course, do that on command line, but it's kind of nice to have a UI. And this is exactly what the dashboard did for you, or does for you if you install it yourself. And this is some networking stuff, the services and the ingress. We don't have an ingress running. If there are any storage volumes or persistent volumes or storage classes are set up by default. So you can do storage and output it to Azure Files, Azure Premium, that sort of thing. Configurations where your config maps and secrets are going to be. So all of this stuff's visible. You can see Helm release packages are stored in a secret to keep it somewhat secure. Secrets are stored secured at rest, but they're only base 64 encoded if you look at them in memory. So keep that in mind. So that's the equivalent to the dashboard, and I believe that's everything I wanted to cover. I don't actually have a end slide. I have all of these resources. So Docker resources, I found these really useful when I was learning Docker and containers, and this one's really relevant because it's not just Docker, but it's taking Docker beyond and running in Kubernetes. This was really useful. Here's this basically the docs for the container tools and everything it does do. This is just a blog entry on them. This was a really good talk on microservices, Docker, and Kubernetes. 55 minutes long. It's kind of long, but it's really good for getting started to get the concept of all the pieces involved. Learning path for Kubernetes, it takes you many days. I forget how many days to actually go through that, but it's a mixture of tutorials, and there is one of the tutorials in here is the tutorial that will walk you through setting up a DevOps pipeline, as along with many other things. This is a really good overview of the pieces of Kubernetes. It's nice to visit after you've played with it for a while, because then it makes sense of it. It helps it gel. Some resources for Helm. Helm, along with a lot of the Kubernetes universe, has a Slack channel. So once you get on that, you can easily just add the different channels with Kubernetes related things. DevOps resources, here's some interesting links. And AKS in general. This is actually the most recent one. It was pretty interesting. Here's a link directly to that workshop that will walk you through setting up the stuff step by step. This compares EKS, JKE, and AKS. This is actually pretty good. Oops, it's not very long, but it's really interesting. And that's it. If anyone has any other questions, go ahead and post them or come off of mute and ask them. If not, I guess we can wrap up. Cool. All right, awesome. Good, thanks. Yeah, and feel free. So let me go back. Wrong one. Feel free to reach out to me either on Twitter or email if you have any questions. I'll try to get them answered. All right, I guess that's it, guys. Veronica, did you have any announcements to finish up with? I will share the deck. I'll if you look at I'll put a link on the meetup for where the deck's going to be. That way you can just go back to the meetup site. Sorry about that, Bill. Let me unmute you. Oh, shoot. You are permanently muted. You're going to have to leave and come back, Bill. Oh, it shows you're off mute now. Can you talk? I hear you.
I can hear Bill.
All right, cool.
Okay.
All right, you're back.
Phew. So I didn't have any further announcements other than that to remind folks just to come back, check the meetup sites, and we'll be announcing shortly our first quarter, the beginnings of our Q1 2021 schedule.
I had two things. The reminder about our YouTube channel. We have all our recordings there, and we'll post this one probably later tonight. And another, I kind of mentioned that IoT event. It will be a free IoT virtual event in January. So let me share both those links. So the first one is for our YouTube channel. Second is for the IoT virtual event. It's Azure IoT, so really related to the main topic of our group. And yeah, thanks for joining us, and happy holidays.
Yeah, thanks everybody. Happy holidays. All right, we're out.
Awesome. Outstanding job, Jason. Such high level, like understanding coverage, and then down and dirty.